Let's talk about what functions are. So the official definition is that a relation qualifies as a function if each input has exactly one output. So in the kind of normal setup, we're assuming the inputs are x's and the outputs are y's. So if that's the case, we could also phrase this, instead of just saying like it is a function, we would say y is a function of x. This means the exact same thing as just saying it's a function. And this kind of gets us closer to the function notation. Y is a function of x, the y equals f of x notation. Technically, we can also get fancy and change up the lettering. So the x and y are kind of our default input and output letters, but we can make the letters whatever we want. So if you ever saw a problem that said like a is a function of b, now you're just saying this a right here is the new y, so this is the output. And then b is playing the role of x, so you're assuming that this is the input. So if you were testing if this statement is true, you're trying to say if I put in any b value, am I only ever getting one a out? Okay, so let's do some examples where we're answering the question, is this a function? So I have an example here that kind of simplifies the situation. It is possible you're given a set of points for this question, but typically it's from a formula or a graph. So for an example, if you have either a graph or a formula where 2,7 and 2,10 are both part of the curve, right? So when you plug in 2 as an x value, it has both 7 and 10 as y values. That would make this not a function. No matter what else is happening on the curve, it could do all kinds of stuff and everything else could be perfect. But because the input 2 has 2 different y values or outputs, that makes this situation not a function. All right, so let's talk graphically. So if you're given a graph and they ask, is this a function or does this show y as a function of x? We are using what's called the vertical line test, which is just sort of like the graph version of that same definition. So it says if any vertical line can hit the graph 2 or more times, then what you're looking at is not a function. So I've got 2 examples kind of pre-drawn here. One of these graphs is a function and one is not. So the vertical line test is talking about like any vertical line. So for this first example, we think like, oh, if I draw a vertical line right here, then I only intersect the graph at 1 point, so we're good. If I do a vertical line here, only 1 point, here, only 1 point. No matter where you draw a vertical line, you cannot cross the graph more than once. So this is a function. However, the second example is not a function. There are some vertical lines you could draw, for example, right here, that cross the graph only once, which is function behavior. But because there is a spot where if we drew exactly this vertical line, we're crossing it more than once, that means that this is not a function. And really what we're looking at in this case is that this one x value right here, all 3 of these points have that x value, and then you have a different y value, different y value, different y value. So this means that there are 3 outputs for this one input, whatever it is. All right, so this brings us to the situation of it being from a formula, which typically is the most annoying version of this question. So just here's a formula. Is this a function or not? And typically it's x's and y's, and they're implying is y a function of x. All right, so again, I have 2 examples prepared. One is a function and one is not. So my recommendation, if it's from a formula, is to try solving for x. Or sorry, try solving for y. It's not always possible if it's like a really, really gross formula, you can't solve for y, but typically the ones we see, it's doable. All right, so let's see what happens when we solve for y in each of these, and this will start to build our intuition about how to answer these. So this first one here, I'm looking at it. I don't really have any idea what this graph would look like, but that's okay. If I solve for y, I'll subtract the x squared onto the right-hand side and then divide both sides by 3. I have y equals x minus x squared over 3. And I still don't have a sense of what this graph looks like, so I can't use the vertical line test, but I could think like any number I plug in for x, I have that number minus its square divided by 3. That's a computation, and it's only ever spitting out one single y value. So this guy is a function. And what really kind of clarifies the situation is comparing it to what'll happen over here. So again, I'm going to try to solve this for y. You might recognize this formula, x squared plus y squared equals a number, as the formula of a circle. And then you could think, oh, it's a circle, I can use the vertical line test. Let's pretend, though, for now, that we don't know what this graph looks like, because that makes the problem a little bit harder. So again, I'm solving for y. And here's the difference. So when I square root both sides to get rid of the square on the y right here, I'm not actually square rooting both sides. I'm plus or minus square rooting both sides. So I'm going to do this in 2 separate steps. This is actually us undoing that square. So over here, it cancels and you have just plain y, but then you have plus or minus root, 3 minus x squared. And this plus or minus is the dead giveaway, right? So if I plug in a value for x, let's even say 0, then I'll get 3 minus 0 under the root, but I'll get positive root 3 and negative root 3. So that's 2 outputs that go with 1 input. So that makes this not a function. Okay, so the big takeaways between these 2 examples is anytime you solve for y and a plus or minus pops out like this, which would happen anytime you're undoing a y squared, that's going to give you, at least for some x values, 2 different y's as outputs for a single x. If you just get y equals like a normal looking formula of x, it probably is a function and you don't want to overthink it. If we trace that back to the original problem, that tells us that y squared in the formula is a dead giveaway. So very, very often, it doesn't have to be there, but very often, as soon as you see y squared in a formula, that's your tip off that it's not a function, because this plus or minus is going to pop out when you solve for y.